Welcome to Data Protection Gumbo, episode 25, and I am Demetrius Malbro, your Chief Data Protection Chef. And Data Protection Gumbo is set up with the aim to expand the awareness of the IT industry by being a voice for protecting all types of digital information. This is part 3 of our series with DATOSiO, where we will cover the problem that currently exists with backup and recovery of scale-out databases. And DATOSiO solves new data management challenges for cloud and big data databases so that enterprises can confidently deploy and scale their applications without worrying about data loss. And today we're joined by Shalabh Goyal, Product Manager at DATOSiO, and special guest Aaron Morton.
Thank you, Demetrius. I wanted to introduce Aaron Morton, an Apache Cassandra core committer, who we are very fortunate to have join us today. Aaron has also co-founded The Last Pickle. It's a consulting practice for Apache Cassandra. Aaron has been working with software and different type of databases for over more than 17 years now, and he was voted a DataStax MVP by the community. He and his organization Last Pickle helps organizations worldwide to onboard Cassandra. So he has a fair bit of experience with Cassandra and different use cases that go along with Cassandra. He will cover some of the things that he has learned along the way in helping organizations across the world get the best out of Apache Cassandra. So thanks for joining us, Aaron.
All right, great. So glad to have Aaron, glad to have you on board. Let's go ahead with the first question that I have. I'm very excited to go ahead and finally have you on the podcast with Shalabh. So I guess first question, can you please share, your perspective on why enterprises are adopting Cassandra databases?
Yeah, thanks, Demetrius. I think there's 4 key reasons. There's availability, scale, performance, and cost. Availability is a really simple one to get your head around. Your systems need to be online 24/7. But when you break that down, there's a lot involved in that. You need to be able to do your operations work continually around the globe in large organizations, not just at night in Pacific time, continually around the globe. You need to be able to handle outages in your infrastructure. If you're moving on to cloud-based infrastructure, you don't control when your infrastructure is available. A couple of years ago, there was the AWS restart again, where they went along and restarted lots of nodes for a lot of people, rolled that across the different availability zones. You need to be able to handle those situations, and you don't want to be the latest company mentioned in the article about who went down when AWS had an outage. And you want to be able to maintain that availability when you're doing major infrastructure upgrades. It could be that you need to redo some networking infrastructure. It may be that you've been acquired. And we've been through this with a couple of companies. They get acquired, they need to move into the corporate data center, and it's a big change. You might be moving off AWS onto dedicated on-premise hardware, and you want to be able to do that change with zero downtime, because your customers don't really care that you got acquired. They may be happy for you, but they just want their systems to work. When we start to look at scale, we see now that even the smaller startups have many terabytes of data. We have systems, gaming systems out there with hundreds of millions of users. We're starting to see systems with tens of millions, hundreds of millions of connected devices sending data. We're collecting data all the time from lots of different signals. Advertising technology is a good one for that. And when we get into scale, we see that scale is linked to availability. The more scale you have, the harder it is to maintain availability. If you've got one node, and that one node has a 50 megabyte database on it, it's easy to keep a backup and restore that straight away. If you've got nodes with hundreds of gigs or hundreds of terabytes around, it's very hard to maintain scale and availability. And when we get into performance, we want to make sure that we have really fast write performance, which Cassandra does. We want to have very, very good read performance, which Cassandra does. And we want to maintain high concurrency. It's not just the database that scales out. It's the entire application that scales out. And you could have an auto-scale group sitting there in Cassandra, perhaps, sitting there in AWS, and the number of clients that are talking to your database is growing in peak times and shrinking overnight. And Cassandra handles that very well because we don't have any locking in the write path and the read path. And it's a highly tuned code base that's under constant revision. And lastly, we've got cost. Obviously, Apache Cassandra is an open source software. It's free to use. You can go to DataStax Enterprise if you want to get support and you want to get the additional features that come with DataStax Enterprise. So what we see is companies are spending money on the services to keep the infrastructure running and less money on the actual infrastructure themselves.
Okay, great. So which applications are most commonly being deployed on Cassandra today?
The classic application that you'll see when you go and do trading for Cassandra is a time series database. The hello world of that is you're recording the temperature of someone's fridge every 5 minutes or something like that. You can also just have your standard database CRUD operations. Anything around storing users, real-time advertising targeting, that stuff is really just CRUD things. Basically, almost any database application now can sit on Cassandra. We don't support full text searching, but DataStax Enterprise, which uses Cassandra, has support for storing data in Solr, and Apple have recently open sourced their SASE indexes, which allow them to do some full text-like queries on their data.
Okay, so recording the temperature of a refrigerator, really? So I guess that's really IoT at its finest, and we're probably at the precipice in the beginning of having devices like that, sending data and information on the back end so it could be analyzed later, right? So that goes into my third question. So why do I need to back up my Cassandra database, and doesn't it just like automatically store multiple copies of the data?
You're right. It does store multiple copies of the data. Think of them as replicas. They're digital replicas. There's no primary. There's no secondary copy. They're just all exactly the same. And it does it very, very fast, but it has no concept of whether you want that to happen or not. You put some data into Cassandra and we store it. We put it in multiple copies and we do that for availability. If you put the wrong data in, we'll copy that around just as fast as the correct data. So when we talk to customers, we say there are 3 reasons why you might want to run a backup. Some good business continuity planning and disaster recovery planning. For example, what do we do if we lose the data center? How do we bootstrap the system? We may need to do that for compliance. If you're in a finance or a heavily regulated environment, you need to be able to, as well as having high availability, understand how you're going to restore your systems. You may want to do some environment cloning. You may want to take production, stand up a QA environment, do some testing using all the data in production, run that for a week and then throw it away. Perhaps you're expanding into a new geographic region. You're adding, for example, US West 1, and you started over in the East. And the simple solution sometimes is just to clone your entire environment over to the new system. And lastly, you might want protection from bad deployments, point-in-time recovery. You deploy some code at 12:05, you realize that at 12:40 that code was wrong. You roll it back. What changed in that time? Can we roll back those changes? How do we understand what happened? Really that level of point-in-time recovery that when you're learning to be a DB admin on a relational engine, they teach you. It's very hard to do in a distributed system because we don't have these synchronized clocks. Machines are doing things at different times. We've got issues around concurrency and as well, and consistency. And so that is the hardest problem to solve in the distributed database.
Okay, great. Fantastic. I appreciate that information. So now down to the nitty-gritty. We're in part 3 of the series, and I think it's about time that you can share a real example from your own experience when customers lost data, and how did they recover from it? I mean, were they able to recover the data?
Yeah, we have the classic RMRF story for this. We get referrals sometimes from people in the industry where somebody's got a problem and they think we can help, and so we'll jump in there and do some firefighting. It was a company, they had a 12-node cluster, 6 nodes in each data center. One data center they use for analytics, one data center they use for transactional data. For whatever reason, they wanted to clear down all of the data on the analytical side to rebuild it or some such, and they accidentally RMRF'd all the data on all the nodes on their production cluster, and then they called us. What we did was we worked with them, and they pulled the data off the file system journals, the fragments of the files, as much as they could scrape together, gave us those fragments. We spent 3 to 5 days writing code, taking the Cassandra code base, working out how we could try to resurrect the data. So reading fragments of files, working out where rows were lost and casting those away. Not the sort of work that everyone can do. And I think we got around 15-20% of their data back. So that did not end well for them.
Wow, it sounds like trying to put Humpty Dumpty back together again. Reading fragments of files. All right, Shalabh, I guess I have a question for you. How does DATOSiO ease the pain that is associated with recovering, data for today in Cassandra databases or Cassandra environments?
So at DATOSiO, we are working very hard specifically to solve this challenging problem that Aaron just mentioned. We developed a scale-out database protection software to solve the challenges of protecting distributed databases. It's really simple to deploy. You can deploy it on-premise, or you can deploy it natively in cloud, Amazon Web Services or Google Cloud. It uses bare minimal infrastructure for deployment, and you can deploy it on bare metal servers, on virtual machines, and it's really lightweight in terms of deployment. But once you deploy it, it provides a lot of flexibility to define backup SLAs per the application requirements. For example, if you choose, you can back up certain tables at an hourly interval and others at daily interval. Then it's operationally resilient to failures. Most of these distributed databases, the failures are bound to happen. They happen very frequently in these distributed databases. But we make sure that the backup process and the recovery processes that DATOSiO starts, they continue even if there are database or database node failures. So this really provides a lot of robustness that enterprises seek in their backup systems. Now, in terms of the key features, we have built the software so it can scale out, both to provide high availability and increased performance. And then the process of versioning that we have introduced in this product ensures that the backup copy is cluster consistent, which really means that when you recover, there are no repairs. You can easily restore the data back into the same cluster, or if you wish, you can restore it in an alternate pre-production or test dev cluster. So it really gives you that flexibility from that perspective. And finally, just to reiterate the point that this software is built specifically for protecting distributed databases. We have introduced this industry-first semantic deduplication feature, which removes all the replicas and stores just one golden copy. Not only this, we offer advanced features such as handling of the TTL data in Cassandra or handling compaction, which is a prominent feature of Cassandra, so that you don't back up the compacted data again and again and again. So overall, it's a robust product built to reduce the likelihood of data loss in your application environment.
Okay, great. Thanks, Shalabh. Aaron, what is your view on DATOSiO data protection product for Cassandra, and is this going to help enterprises onboard Cassandra better?
Yeah, definitely it will. Like everything in this world now, there's free and open source ways of backing up Cassandra. We've had some scripts out there for a while and different ways to do things. They don't provide the level of functionality that most people are looking for. They don't do things like deduplication on the back end, so storage size can become a problem. And they don't have the level of management that you want. Setting up a cron job and hoping that it keeps working type thing. So the companies we talk to want our solution. They want something that they can install, that has good monitoring on it, that has the type of policies that Shalabh was talking about. I'd like to back up this table more than that table. The temperature, for example, of someone's fridge, I need to know that at a one-day granularity. How many fridges they've got and their billing information, I want to keep that in a very tight backup. I want to have, say, a 15-minute window of changes on that. So I think the level of additional management and services and functionality that Datos bring will make it easier for enterprises to get on board.
Okay, thank you. I appreciate you providing your opinion on that. Thank you so much, Aaron. So now let's talk about financing. Let's talk about the pricing. So, Shalabh, how is the DATOSiO software priced, if you don't mind sharing?
Sure. Happy to share. So we offer a very simple pricing structure that's based on capacity tier model. So you just buy the protected data capacity, which is measured in terabytes. The way we define the protected data is the on-disk data in your primary database that is being protected by DATOSiO. So you can easily forecast the growth and you can buy the terabyte capacity as it suits your growth needs. And once you're done with that, you don't need to worry about the licensing costs if you're increasing the number of nodes in your cluster, if you're decreasing the number of nodes in your cluster. A lot of people do that. And moreover, if you want to bring up another cluster and you want it protected by DATOSiO, you don't have to worry about licensing at that point. You just buy the terabyte licensing and you're done with it. The software is licensed annually based on a subscription license and it includes our enterprise class support. And if you're looking to try out the DATOSiO software, I welcome you to contact us at info@datos.io and we can set you up with a sandbox environment to play with.
Okay, I might have to take you up on that offer, Shalabh, and see can you set me up in the sandbox environment? I love to play in sand, so just be ready for me when I reach out to you. Okay?
Sure, Dimitris.
Guys, it's been great. It's been fantastic. We are out of time. I really appreciate the both of you coming on the show once again. Part 3 was great, and I just really have learned a lot about distributed databases, Cassandra, a little bit about MongoDB, and also that I really have a sense that my refrigerator will be becoming more important than my dog. I appreciate you coming on Data Protection Gumbo.
Thank you, Dimitris. Thanks, Aaron. Bye.
Thank you so much for listening to Data Protection Gumbo, and you can check us out at dataprotectiongumbo.com, iTunes, or just Google us. You can also follow me on Twitter at @dmalbro, and you can connect with me on LinkedIn. And also, I am proud to announce that we have now reached over 10,000 hits a month on the website. So thanks to all of the listeners, fans, and the feedback that you have been providing me, which has helped me improve the show tremendously. Thanks again, and see you next time. Have a great week.